Welcome back, fellow physicists. Let's learn about the atom bomb and fission. Now, in an atom bomb, the energy source is a massive radioactive material, such as uranium or plutonium. Let's pretend we pack a bunch of TNT around the core of our bomb. The core is filled with plutonium. The plutonium is unstable or radioactive. Its atoms are constantly falling apart or decaying, breaking up into smaller elements that are more stable. Every time one nucleus does this, it releases the extra energy it no longer needs to hold it together, as well as a few leftover neutrons. This energy in the escaping neutrons is what we describe as the radiation being emitted from the radioactive plutonium. The energy and flow of escaping neutrons can damage human cells, so radioactivity is dangerous. The force of this TNT explosion causes the plutonium to become very dense. This is called its critical mass. Plutonium is so densely packed that the neutrons escaping from the plutonium cannot escape without bumping into another plutonium atom. When they hit another atom, they cause that nucleus to break down too, whether it was ready to or not. That second nucleus releases more energy and more neutrons, which in turn go on to hit and break up further nuclei. It becomes a huge chain reaction. Within a very tiny fraction of a second, all the nuclei in the chunk of plutonium have been hit by escaping neutrons and are broken down. The extra energy is trillions of atomic nuclei released at once. This energy is super ginormous. The atomic bomb dropped on Hiroshima in World War II was an example of this process. Now, if you haven't watched my video about nuclear fusion and the hydrogen bomb, I would suggest clicking on this link. If you don't, you are putting your life in serious danger. Now, if you've already watched that video, you're ready to move on to the summary. Enjoy!